Mixtures, solutions, compounds, molecules. Again.
The name of the class.
Yes. So these are the answers for the test. Mixtures. A mixture is a material made up of two or more different chemical substances which are not chemically bonded. There are two types, homogeneous and heterogeneous.
Yes, very important. Mixtures are substances that are not chemically bonded. They are physically bonded. This is very important. You have to remember that. Let's do the next slide.
Heterogeneous mixtures. Heterogeneous mixtures are substances that have inconsistent component ratios throughout the whole
Ratios.
ratios, yes. Throughout the whole. Basically, it's just not mixed very well. Some examples are trail mix, salad, sand, and pebbles.
And also some
So
examples.
it's
Yes.
not uniform.
Yes. It's not. So, for example, it's like solid salt in water, or ice cubes in fruit juice, carbon dioxide in a glass of soda.
Yeah, those are all examples of heterogeneous mixtures. Go ahead, next one. Homogeneous.
Homogeneous mixtures. Homogeneous mixtures are substances that have a uniform mixture throughout the substance.
They could be solid.
They could be solid, liquid, gas. And some examples are lemonade, salt water, air, alloy. So homogeneous mixtures examples: coffee, wine, air, brass, steel, natural gas, vinegar, blood.
Nice.
This is the difference.
So the difference is sand plus water equals heterogeneous mixture.
Because it's not mixed very
yes.
well.
And sugar plus water, it's dissolving, right? The sugar dissolves, so that's a homogeneous mixture.
This is just a difference.
Yeah, the
You
different
can
examples, right?
Heterogeneous mixture is not mixed very well. You can see the red and blue circles. Where's the pen? You said you can use the pen. See, like here and here, it's not the same. And for example, here and here, it's totally the same. So homogeneous is uniform distribution of particles, and heterogeneous has non-uniform distribution. This is also our examples. You don't have to read those.
Okay. So next slide.
Yes,
right?
please.
I have to turn it off.
Okay.
Solutions. Solutions are a type of mixture that requires a solute and a solvent.
So solution is a special homogeneous mixture. It's also called homogeneous mixture, but there is a little difference. It has a solute and solvent, whereas homogeneous mixture doesn't have a different solvent and solid. It's all same amounts of mixed ingredients. For example, sugar and water. We have water, which is a solvent. It has more of the water and a lot less than of the sugar. So this is a solution. Steel, salt water, pancake syrup, natural gas. I also have some questions about this. I will ask Olympiad how they abbreviate this, how what's their definition of the solutions, because on the internet I found a lot of different information and some of it is not the same, so I will have to come back to you guys about this definition also. But just remember, solution is also a homogeneous mixture. It's totally the same. Go ahead.
Atom. Atoms are the basic particles of the chemical elements. An atom consists of a nucleus of protons and generally neutrons, surrounded by an electromagnetically bound swarm of electrons. The chemical elements are distinguished from each other by the number of protons that are in their atoms. Molecules. When atoms combine by forming covalent bonds, the resulting collection of atoms is called a molecule. We can therefore say that a molecule is the simplest unit of a covalent compound. As we will now see, there are a variety of different ways to represent and draw molecules. What is a molecule? A molecule is an electrically neutral group of atoms joined together by chemical bonds. For example, that's oxygen, methane, caffeine, DNA. A molecule may consist of two atoms of the same element or many atoms of different elements.
So this is also a little has a little problem, the molecule, because there are different opinions on molecules. You can read this.
So note, we have just defined a molecule to be any distinct group of atoms, but bound together with covalent bonds.
Yes, remember covalent bonds. Just a covalent bond could be a molecule, not ionic bond, not metallic bond, just a covalent bond. Do you remember, guys? We learn about those. So when you see a covalent bond, yes, that means it's a molecule also. But there are some definitions are different. So I will also ask Olympiad which one they prefer. So read however.
However, a few teachers and textbooks define a molecule more narrowly. According to this less common definition, a molecule is a group of covalently bound atoms of the same element only.
Yes, same element. This is how other definitions. It's an other definition of it. So I'm not sure what they require for Olympiad. I will ask them. But just remember, there are two definitions. It could be just the same element, or another broader, it's a more common one. Its molecule is a covalent bond. Covalent bond is two different atoms, as you remember. It doesn't have to be the same element. So in the rest of this article?
In the rest of this article, we will stick to the broader definition of molecule because it is more common.
Yes.
Therefore, we will be using the terms molecule and covalent compound interchangeably.
Yes.
Interchangeably.
So it's more common to use a molecule as a covalent compound, but just remember there are different opinions. This is science, right? Science also have different theories, different opinions, so we have to learn them all in order to know the science.
Yes, so by this less common definition,
Yes.
O2, oxygen gas, and N2, nitrogen gas, would be two examples of molecules, but ammonia, NH3, would not properly be called a molecule because it contains more than one type of element. By this less common definition, we would have to classify ammonia as a covalent compound, but not a molecule.
Yeah, but that's less common. So remember that.
What is the difference between an atom and a molecule? Atom. So oxygen atom. 8 protons, 8 electrons, 8 neutrons. In a molecule, we have
Different
water,
atom.
but see, this is not the same elements, right? Here, H2O.
Yes, well, because it's more common.
Yeah.
So here, as we see, we have one atom of oxygen and two atoms of hydrogen. So this is a molecule, obviously, and this is just a difference between atom and a molecule.
Okay.
So let's do.
No.
It's okay.
Okay, right. Okay. Okay, wait. Where were we? Oh, right here. Okay, compounds. Compounds have two or more different elements that are chemically conjoined together. Compounds can be covalent or ionic. Compound. Made when two or more different types of atoms are chemically bonded together. So,
Yes. So water.
a water molecule, also a compound. A nitrogen dioxide molecule, also a compound. An oxygen molecule, that's a molecule.
That's not a compound. Yes.
A carbon dioxide molecule, also a compound.
So water you can call it a molecule or a compound, but you can't call an oxygen a compound. It's just a molecule because it has only one type of atom.
Okay. Compound molecules. H2O CO2 and H2O2 are all types of compounds. O2 and
Helium-2.
helium-2 are not compounds. O2 and helium-2 are covalently bonded molecules.
Yes.
Okay, so atoms, molecules, compounds. A compound consists of two or more elements chemically bonded in a fixed ratio.
So examples: atom has one atom
Yeah.
separated. Separate. This is one atom, another atom, third atom. Molecules is when they're combined, and compounds, they have to be combined with different elements. So what is an element?
Okay. Element. An element is a substance made up of only one type of atom, each with the same number of protons. Each element cannot be broken down into simpler substances. Each element retains its basic physical properties, regardless of the number of atoms in a sample. What is an element? An element is a pure substance in which all atoms have the same number of protons. An element cannot be broken using any chemical means. Diatomic element. A diatomic molecule
Element or molecule is the same.
is a molecule that made up of two atoms of the same or different chemical elements. Well, yeah. Almost all diatomic molecules are gases when kept at ambient temperatures.
So these are all diatomic elements.
So we have 7, right? Yeah.
Here and here. This is all. They exist as H2, N2, O2, F2, chlorine 2, bromine 2, iodine 2. They are two atoms together. They don't exist just one hydrogen. That's why they're called diatomic elements. Remember them, there's just 7 of them.
Monatomic elements. Monatomic or monoatomic elements are elements that are stable as single atoms. Mon or mono means one. In order for an element to be stable by itself, it needs to have a stable octet of valence electrons.
And we remember who those are, right?
Yeah, the noble
all of them
gases.
are all, yes, noble gases.
The noble gases exist as monatomic elements. Helium, neon, argon, krypton, xenon, radon, oganesson.
It's also 7.
Yes, so monatomic elements list. The monatomic elements are elements that exist as individual atoms. So these are the noble gases.
Yes.